Start recording. Okay. So we stopped at chapter 4 series. Okay. We did this chapter 4. We have two parts of the for this topic. We have sequence and series for AP and GP. Okay. So already described about what exactly is AP and GP here. Okay, and how do we actually do the questions? Okay, so as you can see, you have all your exercise here, that what you're supposed to do. Okay, I hope that you actually do the exercises. Then from here, okay, your AP, GP, and your mixed exercise questions. Then today we're going to continue with the second part of this topic, which is binomial expansion. Okay, so let's going to look at this. Okay, chapter 4. Okay, series. Okay, second part, which is a binomial expansion. Okay, binomial expansion. So what exactly is a binomial expansion here? Okay, before we actually start, let's look at some introduction first. Okay, so from the algebra expansion that we did previously, okay, we have a plus b, let's say power 1. Okay, that means it's just one bracket itself, isn't it? If we remove the bracket, I will have just a plus b. Then if let's say I have a plus b squared, that means I will have a plus b, then a plus b again. So I open the bracket one by one. Okay, so a times a squared, a times b, a times b, and you have a b squared. So in the end, I have a squared plus 2ab plus b squared. Okay, so if I have a plus b power 3, okay, so that means I need to open up three brackets. Okay, luckily from previously, I already did the two brackets. So all I need to do is continue with the open up the bracket together with a squared plus 2ab plus b squared together with a plus b. So if I open up the bracket like this, again, we're actually expanding bit by bit. Okay, so a squared with a, I have a cube. 2ab and a, I have a 2a squared b. Okay, and a b squared with a, I have a b squared. Then b, so I have a squared b. Then 2ab with b, I have 2ab squared. B squared and the b, I have a b cube. Then if I simplify the form, I will have a cube, 2a squared b, and the a squared b here, a total of 3a squared b. Okay, ab squared and 2ab squared, here I have a 3ab squared and b cube. Okay, so if I expand it further, okay, to skip the working, so I have a cube plus 3a squared b plus 3ab squared plus b cube. Okay, this one you can try to write the algebra yourself, and in the end you will get something like this: a 4a cube b plus 6a squared b squared plus 4ab cube plus b4. Together with everything that we have here, there is something that we actually can observe. Okay, what can we observe? Number one, okay, I have the a plus b. Okay, I have a squared plus 2ab plus b squared. I have a cube plus 3a squared b plus 3ab squared plus b cube. I have a4 plus 4a cube b plus 6a squared b squared plus 4ab cube plus b4. what you can observe is, okay, A is in decreasing power. B is in increasing power. And the number actually following a certain pattern, that actually following the pattern, a pattern like this. So 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So if you can read the number, so 1a and 1b, so 1, 1. So 1a square, 2ab, and b square is 1, 2, 1. Then the a cube, okay, a 3a square b, 3ab square, and b cube at 1, 3, 3, 1. Then the power 4, 1 a4, 4 of a cube b, 6 of a square b square, 4 of ab cube, and the b4 you have a 1, 4, 6, 4, 1. How do we actually create the number? Okay, how do we actually create this number? So you need to know, okay, this pattern here is called a Pascal triangle. Okay, this number here is called Pascal triangle. And this Pascal triangle, okay, so when n equals to 1, okay, we have a 1, 1. When n equals to 2, I have a 1, 2, 1. When n equals to 3, we have a 1, 3, 3, 1. When n equals to 4, you have a 1, 4, 6, 4, 1. What actually happened is the following row, okay, the following number is actually addition from the neighbor of the previous two. Okay, so you can see 3 plus 3 here add become 6, 1 and 3 here add become 4. You always start from 1. So by using this concept, I managed to get n equals to 5. Okay, 1. I start with 1. So the sum of the two neighbor, I have 5. The sum of the two neighbor, I have 10. The sum of the two neighbor, I have 10. The sum of the two neighbor, I have 5, and n is 1. So how do we actually recognize these numbers? Okay, so the number here, okay, we start with, okay, we call this as first row, position 0. Okay, we start counting from position 0. So this is position 1. So that also means this 3 here is third row, position 2. Okay, so 0, 1, 2. And therefore, this 1 here is fifth row, position 5. So this is how we actually read the form. You can see that if let's say I have a n, I want to find the number for a certain n value, let's say for n equals to 10. You need to do construction for the previous line, then only you can actually find all the numbers here, which is very troublesome. Okay, by identifying the row and the number, okay, I know that this the first one I will have the 10 row 0 position, 10 row first position, 10 row second position, and so on. So we can actually use, okay, it can be represented by using NCR. Choose NCR. That actually give you n row R position. Okay, we can actually use calculator. So let's look at calculator. Let's see calculator. Okay, show. Okay, where is my calculator here? Okay, image. Copying. Okay. So if you look at our calculator here, okay, you will actually see NCR from this button. Okay, actually, okay, you can see NCR from this button here. Okay, so what you can do is, if let's say you want to find the value at 10 row, okay, 10 row second position, then you will be writing 10C2. Okay, then if you press the calculator 10C2, you have a value 45. Okay, you will get a value 45. That means we actually can get this number easily. Okay, so this is a way for us to actually read the form. Okay, so this is the very first part of understanding. Okay, we actually understand about, okay, this one first part we understand. Okay, this is binomial expansion. Binomial expansion, we have front term, this is a back term. Okay, we have a power, then we have a Pascal triangle. Okay, we have a Pascal triangle to here. This Pascal triangle can actually help us to actually get the number. Okay, then comes to the formula, binomial formula. Okay, so therefore, if you have a plus b power of n, okay, so this is a positive integer. Okay, this is your front term. This is your back term. It will equals to summation from r equals to 0 to n. Okay, for NCR, the front term, okay, is powered by the front term is powered by n minus r, and the back term is powered by r. Okay. Okay, NCR, a power n minus r, b power r. Yeah. Okay. So from here, then this is the formula. So as you can see, the 0 here. Okay, start from the 0 position. The 0 position. Then you're actually ending with the n position. Okay, so how do we actually use it? Example, let's say I have 2 plus x power of 5. Okay, we can actually write the form. So I have a 5 summation r equals to 0. For 5, choose r. Okay, the front term 2 will follow by 5 minus r. Then the x powered by r. Okay, so we're going to write them one by one, starting from 0. Okay, so how many numbers I need to fill in for these questions? Okay, 0, 1, 2, 3, 4, 5. Total of 6 numbers I need to fill in. Therefore, the first number I have 5C0, 2 power 5, x power 0. Then the second 5C1, 2 power 4, x power 1. Then 5C2, 2 power 3, x power 2. 5C3, 2 power 2, x power 3. 5C4, 2 power 1, x power 4. 5C5, 2 power 0, x power 5. So all you need to do is just press everything inside calculator and you actually get the number. So this is a 1, this is 32, this is a 1, this is a 5, this is a 16 and x, and this is a 10, 8 and x squared. Then this is a 10, this is a 4 and x cubed. This is a 5, 2, and x4. And you have 1 and 1 and x power 5. So because it's expansion, as you can see from how we actually do the questions earlier, at your last line, you don't have any brackets anymore. Okay, the expansion is to remove all the brackets. So in the end, there will be no brackets. So you have 32. Okay, 32 plus, so 16 times 5, you have 80x. Then this is 80x squared. Then this is 40x cubed plus 10x4 plus x5 as your answer. Okay, during exam, the marks will be given to individual term, whether you got them correctly or not. Okay, so this is how you actually use your binomial expansion formula. Okay, so over here, okay, then comes to, okay, for number 4 is a further discussions. Further discussions for NCR. Okay, under this topic, there is something that you need to know, the properties of NCR. Okay, some book write like this, some book actually write like this, some book actually write like this. Okay, they are all representing the same thing, NCR. Okay, the important thing that you need to understand is the formula n factorial over r factorial and minus r factorial. Okay, so where this one here read as factorial. Okay, so the factorial here actually work like this. Okay, if let's say I have a n factorial, it means that n times n minus 1 times n minus 2, okay, and n minus 3 all the way until 3 to 1. Of course, you can write in the reverse or process, it doesn't matter. Okay, so in other words, n factorial also equals to n times of n minus 1 factorial. Okay, also equals to n minus 1 factorial. So example, let's say for 5 factorial. Okay, what does it mean by 5 factorial? Will be 5 times 4 times 3 times 2 times 1. Okay, so you have a 120 as your answer. Okay, so something special, the special one will be 0 factorial. 0 factorial will read as 1. Okay, it doesn't read as 0, but it will read as 1. Yeah, for information. Okay, this is something special here. Then shortcut way, shortcut method to calculate NCR. This one will be important when you have a reverse question later. Okay, when you have a reverse question later in the exam, you are required to know how to actually do the calculation reversely. Okay, so for example of 5C2, by pressing calculator, press calculator, you'll get a value 10. But the thing is how to actually get what happen if you have a reverse question. Okay, what happen if you have a reverse question? So 5C2 here. So first I draw a line. 2 here means 2 numbers below, 2 numbers above. 2 here means 2 numbers below, 2 numbers above. Okay, the first number above start with 5. Okay, whatever the value that we have here. The first number below starting with 1. Okay, then on top, the following number you keep minus by 1, so you have 4. Okay, then the bottom, the following number you're adding by 1, so you have a 2, and the operation is multiply divide. So what you actually have here is 5 times 4 divided by 1 times 2, therefore it's a 10. Okay, so what going to happen during exam is, okay, you may have unknowns here, ABC. okay, then you need to know how to write in this way. Okay, so other than 5C2, maybe another example, we talk about maybe 7C4. Okay, let's see how do we actually use the shortcut way to calculate 7C4. 4 here means I have 4 numbers below, 4 numbers above. The first number above will be 7, then times by 6, times by 5, times by 4, because you keep minus by 1. The first number below, you start from 1, then followed by 2, followed by 3, followed by 4, because you keep adding by 1. Then do some calculation, okay, regardless whether you are good with mental arithmetic, then you do a mental calculation. If you're not, okay, you can just press calculator. Over here we have some same number from top and bottom, like for example 4 here cancel off, 2 and 3 and 6 here got cancel off, therefore you have an answer as 35. Of course, you can actually press with your calculator 7C4, you will get the value 735. Okay, so this will be the further discussion for NCR. Okay, therefore from here, number 5, you have type of questions, type of exam questions. Okay, so yeah, we can actually discuss on the type of exam questions bit by bit. Okay, A, maybe the question asks you to do full expansion. Okay, so that means just like how we did earlier. Okay, the 2 plus x power 5. Okay, we write out everything. This is called a full expansion. Okay, this is called a full expansion. It can be a partial expansion. Okay, can be a partial expansion. So they only ask you to write up to a certain part. Maybe the question maybe sound like this. Write the first 4 terms in ascending or maybe descending power of x. Okay, so okay, so maybe the question may write write the expansion up to x cubed in ascending power of x. Okay, therefore the question can actually ask you to write up to anything. So full expansion, so but since this is an exam, exam is about 2 hours, 1 hour and 50 minutes. Okay, full expansion usually go for a smaller number of n, but partial expansion they can give you a bigger number, maybe like n equals to 100. So students just do the calculations. Okay, so they're not going to ask you to write a lot of things. Okay, but you is actually testing on students whether do they know how to actually use the formula or not. That's all. Okay, then from here, maybe C, maybe the question asks for finding a certain term, finding certain term. Okay, maybe the question maybe sound like this. Okay, find term of x cubed. Okay, maybe the question asks find coefficient of x5. Okay, so this is actually a certain term. D, the combination of 2 or more expansion. Okay, maybe the questions they actually have 1 plus x, then followed by 2 plus x power 5. So after you do the 2 plus x power 5, you need to do further expansion with 1 plus x. Okay, so this will be a combination. Okay, E, okay, you may have reverse question. Okay, reversely they ask you to do some calculation to actually find the answer. Okay, then maybe there will be some approximation question. Okay. So the question may be use binomial expansion to find approximate value of maybe 101 power 5. Okay, so the question may be asking this way. So maybe since you can actually calculate approximate value, therefore they can be maybe asking for percentage of error, okay, percentage of the accuracy, or even degree of accuracy. Okay, so you can actually slowly work on this type of questions, okay, and try to figure out how to actually do the questions. Okay, I will post the questions here, so you can actually do something with it. Okay, let's see for the questions. Okay, okay, let's see what can we do. Okay. Okay. Okay, let's see. So, okay, let's find let me put the answer as well. Wait for, okay, put the answer as well. Okay. Okay, so you can actually see from here you have some questions. Okay, you actually can try to work on the questions. Okay, anything that you are not sure, you can go back and post to me, ask me about it. Okay, with this is chapter 4. Okay, thank you very much. I'll stop recording.